Hi, I'm Jack Koenig with Graco Industrial Lubrication Equipment, and this is the GLC4400 controller. It's so named because it has 4 inputs and 4 outputs. We don't count incoming power as an input, so there's 4 inputs, 4 sets of 4 terminals, because there are 4 terminals for each input. This can get a little bit confusing, so I'm going to demonstrate that in detail. On this side, we have main power in, and then outputs to the pump itself, and then 3 outputs for fault or OK signals. The 11th terminal is not connected to anything. It's just a dead terminal. Before opening up the enclosure on a GLC 4400, make sure there is no power connected to it. So if it's a pre-existing controller, make sure that you disconnect power or lockout, tagout, whatever you need to do to make sure there isn't any power coming in. The DC version needs to have power locked out as well, but the AC version especially, because there could be lethal voltage because the AC system runs on line voltage. Always wear your personal protective equipment. Usually that's just going to be some safety glasses, but whatever's called for on the job site, just make sure you're respecting that. What I'm going to show you will be how to connect a dry contact switch. Here we have a pressure switch that has 3 wires coming out. We're only going to be connecting 2 of them because one of them is for normally open and another is for normally closed, and then the third is the common. So we're only going to hook up the common and the normally open switch because that's how an injector system wants to see the signal. The other one is a PNP or sourcing pressure switch. This requires a 3-wire connection because it's a transistor. It's not just a dry contact switch. So I'm going to hook that up and show you how to do that as well. All of the sensor inputs will be on terminal J6. Even on an AC unit, this is DC powered. There's a power converter on the AC board that converts everything to 24 volt. So your sensors that you use will always be 24 volt or at least DC sensors. I guess on a 12 volt system, you'd want 12 volt sensors too. And then they're all numbered 1 through 16. And like I was saying earlier, there's 4 sets of 4. So here you can see I've screwed down 4 of the screws because I connected these for the dry contact switch for the pressure switch. This is where you'd also put a cycle switch on a divider valve system. And then each set of 4 are for another purpose, and they're described in the manual as well as on the back of the enclosure box. Let's flip this around now and take a look at how I wired up this dry contact switch. First, let's take a look at the simpler example, which is a dry contact switch. Our pressure switch 557829 is a dry contact switch. As I said earlier, it has 3 terminals, but only 2 of them are used, and with dry contact, you're always just going to have 2 wires that get used. Over here now we can see that this is a jumper. In the manual 313855, you can see this on the dry contact wiring schematic that we put a jumper on pins 3 and 4. So we start counting from the bottom. The numbers are over here where I can't see them off the screen right now, but they are numbered. So 1 and 2, and then 3 and 4. Jumper on 3 and 4, and then our 2 wires from the dry contact go on 1 and 2. If you get these backwards on a dry contact, it usually won't matter, but it could depending on the switch. In my experience, all of the dry contact switches that Graco sells don't really matter if you go negative and positive mixed up, or however you want to look at it. So a dry contact switch is really simple. You just put your 2 wires on the first 2 terminals, and then you put a jumper between 3 and 4. This example is for a PNP proc switch or pressure switch. In this case, I have the 24K414 pressure switch hooked up, but also any of our new solid state proc switches are all PNP, so they can follow the same wiring schematic. And what you're going to find, the color code is going to be the same most of the time when you're using these M12 or Eurofast cables. And that's what we're using on all of these M12 connections. It's a Eurofast, so the coloring for a Eurofast is pretty consistent. Here I've got the white clipped off because White is only used with normally closed pressure switches, and we want to do this normally open again. Down here we have the jumper here. It's hard to see because I don't have the insulation on it, but there's a little jumper here between pins 3 and 4. Pin 1 gets the brown cable, pin 2 gets the black cable, and then 3 and 4 are connected, so the blue can go on either 3 or 4. In this case, I stuck it on 3, and then I made sure that both the blue wire and the jumper are secure in that terminal. And that's how you wire up a PNP sensor. To reinforce what was just demonstrated, let's take a look at the actual label that we put inside the enclosure. Here you can see brown goes to terminal 1, black goes to terminal 2, and then 3 and 4 both are touching the blue wire because that's what the jumper does. So the jumper connects pins 3 and 4, and the blue connects to either one of them, and because of the jumper, it's really connecting to both. This is going to be true of anything that wires up normally open that uses the same wiring diagram. So that includes our 24K414 pressure switch, our 24K415 proximity switch, as well as the new solid state proximity switches. If you use one of these proximity switches up on the machine count, that would be the same. So 13 would get brown, 14 would get black, 15 and 16 would get a jumper, and then the blue wire would connect to 15 or 16. Same thing, regardless of which set of 4 that you're using. However, if you want to wire your switch to be normally closed, then you're going to use the white wire instead of the black wire. So now we're looking at this example of a low-level switch, specifically because the Dynastar low-level sensor that we came out with a few months ago is actually wired normally closed. Now brown goes on 5, and the blue still goes to the jumpered 7 and 8 connection, but the difference is that instead of the black wire on 6, we're going to clip the black wire off and use the white wire. So it's just another example of another way to do this wiring, and it's not really the 4400 that's changing this, it's the switch. It's just case in point that you need to also look at the manual and the wiring diagram for the switch or sensor that you're using and combine that with the GLC4400 manual to figure out how to connect these things. Now, as somewhat of a summary, let's take a look at all 16 terminals wired up. Here we have the original 4 that we did for the normally open pressure switch with the jumper back here between 3 and 4. This is our normally closed low level, and a low level can be normally open or normally closed. It just depends on your application. This time we did the normally closed just to show what it would look like with the white wire on there. Here we have a different brand of cable, but it's still going to have the brown, the black, and the blue. This time, because I was clipping off the white wire, I used that as my jumper. It doesn't matter what color your jumper is, you just are connecting 3 and 4. And then again, this is the same thing, another normally open switch on our machine count input. Here we have the wire, which should probably be taped off. You definitely don't want a conductor loose inside this when you put the controller back on the enclosure. Here's the black wire hanging loose. Same thing, you should be clipping that off and taping it up, keeping that conductor away from the circuit board. The point is that you can mix and match. Some of these can be normally open, some can be normally closed. You can also mix in some of the dry contact. They're just simpler to wire, so I didn't spend as much time on these. Hopefully this example has been helpful for you. If you have any questions, don't be afraid to contact Graco. We are always happy to help.